So when we take this double antiderivative, we are going to ignore the constants of integration. So we're just going to integrate twice and not do the plus c part. So go ahead, see if you can knock out both antiderivatives in one step. And you can always guess and check. So any questions on that second derivative? Just guess. I just guessed the powers. I knew they're going to go up by 2, and then check your coefficients.
Do you drop a 3
Yeah.
on the second term?
Uh-oh.
You have 2x cubed be plus x squared instead of plus 3x squared.
Oh. Yeah. Is that right? It'll be 3x, which will be 3. All right, that looks okay. So in general, so we do the nth antiderivative of a constant. It should be x to the nth times c, and it would be divided by n factorial. So you get an n minus 1, n minus 2, n minus 3. So some of these are kind of tricky. If there's a power of x inside, you'd have to think about it a little more carefully. But if you're just anti-differentiating a constant n times, you'll get x to the n over n factorial. So let's consider d inverse of 0. So how do I figure out d inverse of 0? We can set it equal to y and basically figure out what y is. So this is how we did this before. We're going to move the operator to the other side by using the inverse operator. Oh, what do I have? On my notes I have that this should equal 0. Well, we'll just take the convention that when we ignore constant of integration, or that we will ignore constants of integration. So once we know that, d inverse of 0, normally it would be a constant, but we're going to make that constant 0. And so if I did this n times, if I did this n times in a row, I would get 0, anti-differentiate 0. So it would keep being 0. And if I had basically a polynomial inverse operator, so p inverse of d of 0 would always give me 0. So all the operators would give me 0, add them up, and I would get 0. Now we'll look at the algebra of these operators. what should this, doing these two operations, give you?
Q.
Q. So they should cancel each other out. And likewise, if I did the other order, and what should this equal, if things make sense?
Q.
Q. Did I write down the... So for now, you can think of P inverse of D as 1 over, I think I've written this down. I had written this down before, because we're basically treating it like multiplication. So the inverse operator would act like division, or the opposite of multiplication. So that's what, when we write PD over PD, what we really mean is PD times the, or PD and then the inverse of PD. So it looks like division, and because they operate like that, you can actually treat it like division. And what else? Oh, we had the identity operator, of course, which is, if you look above, every operator, if you look at it and combine it together, all those are the identity right there, because you're undoing. They're all actually the same thing, just in different forms.
So we're still, like, assuming we don't get a constant integration from this? Then?
For the inverse operators, yeah.
Okay.
Or else you'll have one of these two wouldn't work out. I'm thinking this second one wouldn't work out in that order because you get a constant at the end and you wouldn't have that in your original Q, basically. So the algebra doesn't work out if you don't ignore your constant.
Is that identity symbol there pretty much?
That's a big one.
Okay.
Yeah. It's it comes from the same font family as that capital R right there.
So is that?
It's called Blackboard Bold, or Math Blackboard Bold, something like that. So solution of, oops, it should be P of D. So it's very tempting to put the word obviously at the end of that sentence. If you read it, it should be pretty clear. All we did was move the operator to the other side. So obviously it's the same exact thing. So how do you solve for y?
Obviously.
Obviously you take the operator and move to the other side as this inverse. Now, how in the world do we compute that thing on the right side? That's a different story. So it's easy to write down.